Mmm, pancakes, bacon, coffee. These are smells that lead us out of our nice warm beds, down the stairs, and to the breakfast table every morning. As humans, we use our sense of smell to make first impressions without even realizing it. Perfume and cologne are ways to make ourselves smell good and are often used to attract others. We gravitate to smells we like and take those we dislike as a sign of harm. This sense of smell may guide birds, just as we are guided out of bed in the morning to pancakes.
It has always been a concept of debate of how birds travel such far distances. According to Paget, navigating while flying over the open ocean is most likely one of the largest challenges for birds, given their vastness and ambiguity when it comes to landmarks. It is possible that birds use their sense of smell to guide when they cannot use landmarks. There has been some debate over what actually causes birds to navigate, especially when it comes to flying over water. Previous hypotheses stated that olfaction, defined as the action or capacity of smelling, did not play a role. Others stated that birds use the Earth's magnetic field as a guide. Previous tests were criticized as the displacement of birds may have caused a behavior change and the sensory deprivation could potentially cause a change in feeding habits. From these previous hypotheses and tests, it remained unknown how olfaction might affect birds' orientation during natural free-ranging movement. Previous experiments involving shearwaters concluded that the species retains motivation to home from short-distance displacements, but return during daylight instead of during the night, suggesting a reliance on visual cues.
To conduct research that could be free of criticism about the role of olfaction in birds, researchers from the universities of Oxford, Barcelona, and Pisa split 32 free-ranging Scopioli shearwaters or Calanictris borealis, a neognathic bird off the coast of Minorca, into 3 groups. The first group was treated with nasal irrigation and zinc sulfate to make them temporarily anosmic or unable to smell. The zinc sulfate solution would cause neurosis of the nerve cells that then would cause the anosmic state until the nerve cells heal, allowing the birds to smell again several weeks later. The second group carried small neodymium magnets attached to the feathers on top of the head. These magnets were attached to test if the magnetic field of the Earth could be a factor that influences the ability of birds to navigate. The third and final was the control group. GPS loggers were attached to all birds in each of the 3 groups, and they were tracked as they engaged in natural foraging trips. The results of this experiment were very interesting. The foraging trips were normal for all 3 of the groups. The birds gained weight and returned to exchange incubation periods with their partners. Based on these results, the researchers initially concluded that removing the bird's sense of smell does not interfere with foraging or the ability to return home. There was a twist to these results, however. The birds without olfactory senses were able to navigate above land, but navigating without smell above the oceanic waters was a whole different story. They embarked on curiously straight but poorly oriented flights across the ocean, bearing away from their foraging grounds and were unable to return home. Their orientation then improved when approaching land. The landmass was able to be used as a marker, allowing the birds to gain a more direct and proper course. This graph depicts the distance that each group of birds were able to fly from the coast of Minorca. As you can see, the anosmic birds, or the ones that could not smell, stayed about 2 kilometers closer to the coastline than the control group. The group with the magnets was able to travel just a bit farther than the control. In addition, the anosmic birds were much less consistent in their time of departure, as well as the paths that they took. These results provide the following conclusion. Olfaction is a key factor for birds in long-distance oceanic navigation, but does not play a factor in the foraging ability of birds, as well as their drive to return home.